Welcome back. In this video, I want us to take a deeper dive into functions that have both arguments and return values. So, I added a few variables just to show you that they would be in the global space. Okay, so let's execute and observe what happens. Okay, so I have a variable here in the global frame. Okay, notice here Python sees that I have defined a function on line 4. Okay, so Python makes a note of that. So whenever I call this name sum of list with parentheses, Python knows that it will go and look in this at this location to find the corresponding code. Okay, so we have another statement here on line 9. Okay, prints hi. And now we create the arguments that we will be using to supply to our function. All right, so that's also in the global frame. All right, so I have my list here. So notice that test list, this variable is sort of pointing to where the list is actually located in the computer's memory. Likewise, the sum of lists function is also pointing to where the code for that function is located. Right? And notice that we call these objects. Okay. Alright, so on line 13 we will call the function. So it means that Python will create that local frame, that frame where all the variables will be hidden from the global frame. Okay, so in blue, this means that this function has the focus. So we will start executing this function on line 4. Okay, the first thing we're going to do is to use the sum function, the built-in function that will find the sum of the elements of the list. Okay, so notice that I have saved that answer in a local variable called result. And I'm going to find the first element in the list. I'm going to save it in that local variable called first. Okay, so notice these two variables are inside this function scope or this function frame, and they're not in the global frame. So it means that I would want to return these answers back to the global frame, because when I leave this function, everything will be destroyed. Okay, so to do that, like I mentioned, we're going to say return result comma first, right? So we could return only result if we wanted, or we could return first, but by putting a comma we return both. Okay, so next, notice that the return value is a tuple, which is a data structure. And this tuple is simply something like a list, except you can't change them once you have the values inside. Okay, so these values can never be changed again. Okay, so the return value will be pointing to this tuple. Okay, so now when I hit next, notice what happens. Everything that we were dealing with in the function has disappeared. But lucky for us, we had returned result on first. So we notice that result contains the 15 and first contains the 1. Now keep in mind, I could have named these variables whatever I wanted. It just turns out that I decided that I should probably give them the name result on first. Alright, so the names that you use here inside the function, does not have to be the same names you use outside the function. Right? But it makes logical sense to use the same name. Okay, so now we can just go ahead and use those results. So the sum of your list is 15, and the first item in your list is 1. Alright, so notice our list that we sent to the function is still here. Okay, and our pointer, in other words, our pointer here still points to the function. Okay, so I want to do one more thing. What would happen if I decided to change the first item in the list, and I say that list underscore to sum 0 is 100. Okay, so let's see what happens. Let's see if this list gets changed. Okay, so we're gonna go here, go here. Okay, so we're gonna be back now to our function, and let's see what happens. Okay, we get 15. All right, we get 1, and notice what has happened. All right, so on line 7, I changed the value of the first item in the list to 100. Now, remember I said earlier that whatever happens inside a function, it's temporary. Well, there are exceptions. Whatever changes you make to a list, then the change is permanent. In other words, it affects the list. And why is that? Well, because if you notice, the test list, it has a pointer, and when we call the function, we are actually passing in the pointer to the list. Okay, so I am not actually making a list in this function and having 1, 2, 3, 4, 5. No, I am actually saying Python, or what Python does, it actually tells my function where to find the elements of the list. And so why would Python do that? Why would it not give me a copy of the entire list? Well, it turns out that the list can be extremely large. Maybe they might have 100,000 items. And to copy 100,000 items and give that to my function would take too much time. And also it would take too much space. And so your program would be extremely slow. So what Python does, and what many languages do, is to simply say, if you're going to use a list, which is a data structure, don't make a copy of all the elements in the list. Simply tell us where to find the list. Okay, that way we save time and we save space. We don't have to make a copy of the list every time. Now, the downside to this is you must be careful, because you must always remember that if you make a change to the list from within a function, that change actually affects the list in the global frame. Okay. Now, this only applies to data structures. It does not apply to variables such as my variable and so on, right? These are always, there's only copies of these. These are never altered from inside the function. Okay, only data structures can be altered from inside a function. Alright, so I think that is the only thing I wanted to clear up. Functions do have the ability to alter data structures from inside. Okay, so be mindful of that if you're going to pass a data structure to a function. Okay, so if you don't want to alter the original list, then we could have simply made a copy of that list. And so let's just do that. Let me make a copy of my list. So I could say copy test list. And then I could simply make a copy of it. So test underscore list. Okay, and if I visualize, we'll see that we are making two separate lists. Okay, so this is the original and this is the copy. So if our function does change the original, then notice that the function is only pointing to the original. The copy is still there, so whatever change we make does not affect the copy. Alright, so that's how you would rectify this problem or overcome this problem if you want to alter the list but still have the original for reference. Okay. Alright, now notice that we did see that the first item in the list, the original list, was 1. Okay. Okay. So the reason why that happened was because we did it on line 6. But if we had put this code after we had changed 100, then obviously this would have been 100. Great. So that takes care of looking at functions that have arguments and return values using Python Tutor. And so next, we will put everything together that we have learned into solving a problem with functions. See you then.